For our case study, we've chose to investigate the manufacturing processes used in creating a coilover shock off of a race car. The spring is manufactured by heating steel wire to an elevated temperature around 1000 degrees C in a furnace. The steel wire is fed into a CNC coiling machine. The coil is then quenched in a bath to increase hardness. After quenching, the coil is tempered to increase elasticity. The ends of the coil are ground flat for proper seating. The coil then goes through a process called shock peening, where steel pellets impact the surface of the coils to increase fatigue life. A clean surface finish is also achieved, which is good for painting and powder coating. To eliminate break-in, the spring is compressed until there are no gaps between the coils. The cylindrical shock body is manufactured starting with a piece of aluminum tubing. The tube is machined by a CNC lathe. This is evidenced from the fine tool marks on the outer surface. A CNC lathe was a good candidate due to the part's complexity of the cylindrical shape. The inner surface of the cylinder is also machined and threaded using a CNC lathe. An alternative method for manufacturing could be investment casting, but would be much lower production rate. The shock absorber rod is made from solid steel alloy round stock. The ends are drilled and threads are machine cut rather than rolled because the diameter of the rod is the same diameter of the threads. Quenching, tempering, and chrome plating are used for strength, corrosion resistance, smooth surface finish, and added hardness to resist chipping. Our team, even with the help of Dr. Lee, were unable to come up with a definitive process used in manufacturing the piston. We believe the piston could be made through investment or lost wax casting due to the complex geometry, internal cavities, and smooth surface finish. An alternative process could be powder metallurgy, but the cost and complexity required in die setup would be too costly for small volume orders. Due to an addition of the plastic seal ring, we are unsure if the part has a parting line or not. The shims used to restrict flow through the piston are blanked from sheet metal. Various different sheet thicknesses are used in order to fine-tune dampening rates. Various blanking dies are also used to change the shim diameter and create bleed notches. The O-rings are made by compression molding. In compression molding, an elastomer material is formed in a two-part heated mold of desired shape. This is evidenced from parting lines on the inner and outer diameters. The mold is set for a specified amount of time depending on the material used. An alternative to compression molding is injection molding, which can have a higher production rate but higher investment cost. The nuts used in the shock are made through a process called hot forging. Steel bars are cut into slugs, which are then pounded into hexagonal shapes while a die pierces through the hole. The nuts are quenched and threads are cut into the nut by using a tap. Lastly, the nuts are tempered to increase strength.